is Professor Cottrell.
Thank you, Alison. It's a pleasure being with you, at least virtually. And what I'll try to do today, I will talk about our studies. I will put Zika in a general pattern of tropical diseases, vector-borne diseases, and issues related to human-made changes. And I'll talk quite in detail about our ongoing studies in Sao Paulo and especially in Salvador, and then raise some other related issues. So with Professor Lesser, who is a professor of history, who has been working in Brazil for decades, we started talking about our intersection of interest in health, migration, urbanization in Brazil. And we came up with the idea of doing a study together on the historical epidemiology of mosquito-borne diseases in Sao Paulo and Brazil in general. We published a paper on the social geography of Zika, raising the point that really issues related to Zika and other mosquito-borne diseases are truly more than just health issues. They're related to demography, to urbanizations, to social issues, to ethical issues, and we try to put much of that together in the paper, and we developed a joint class, which is an environmental sciences, history, and Portuguese and Spanish class, titled Metropolis, Migration, and Mosquitoes, the case of Sao Paulo, Brazil, where we try to put all those topics together with those very interdisciplinary and diverse perspectives. We work together with a group of scientists in Sao Paulo, some of them for the University of Sao Paulo, the leading university in Brazil, some of them with the Museum of Public Health, and a variety of other people. And we also work with people here in Emory, including Ana Teixeira from the Department of Portuguese and Spanish. Throughout our course, we got our students very excited about this project. We're going to bring 4 or 5 students with us to Sao Paulo this summer to work on projects related to Zika and to health in general in Sao Paulo. The pictures you can see are related to the part of the public health campaign, and education campaign about mosquitoes and Zika virus in Brazil. The one in the middle that says Zika 0 says a mosquito is not stronger than a whole country. The one on the right says fight dengue, take care of dengue before it will take care of us. And the one with the very scary flying mosquito says that non-moving clean water, that is the mosquito, the dengue mosquito in this case, really likes. Let me talk a little bit about vector-borne disease in general to put Zika in perspective. Vector-borne diseases are diseases that are transmitted by insects and ticks, for that matter. Lyme disease is a vector-borne disease. Many of them are mosquito-borne. Many of them include also other animals in the life cycle, such as West Nile virus, which includes a variety of birds. Lyme disease, which includes mice and deer in the life cycle. And they're interested for ecologists because it's very difficult to predict and understand their transmission patterns, because we have to think of the impact of the environment and of climate on all the different components of the life cycle. One interesting question is, where do those infections, those pathogens, and those vectors come from? And where will they go to next? West Nile virus came to the US, to New York, from Israel, for example. Lyme disease was probably always around in the northern woods and then spread south to the mid-Atlantic, the northeast, and the upper Midwest. Anthropogenic effects are very important in creating conditions that are conducive to the establishment of pathogens and vectors. In general, there are probably thousands of invasions occurring around the world every day. Most of them are unsuccessful. We really only know about success stories, which are a small percentage of those that actually make it, such as West Nile virus, Zika, and before that, other mosquito-borne diseases such as yellow fever and dengue. There is a whole range of anthropogenic changes: agricultural, forestation, deforestation and reforestation can be important. Again, Lyme disease, for example, came to the Northeast and the Upper Midwest because of reforestation, reintroduction of deer, and providing habitats that allow humans and ticks to be in contact. Climate changes are important. For our point today, urbanization is the most important, because urbanization brings a huge number of people together in a closed environment, in a relatively uniform environment, and provides perfect opportunity for pathogens to move from one host to the other. Underlying it all, of course, is population growth. There are simply so many more of us concentrated in more and more places. So what does it take to have an active transmission of a vector-borne disease? Well, the vector, in this case a mosquito, has to do really well. If we talk about reservoir hosts, such as birds or West Nile virus, they have to be around. The pathogen, the virus in this case, has to be transmitted between the different hosts. And finally, there have to be opportunities for human exposure. There are many wildlife diseases that have never spilled over to humans. Ebola, for example, is probably circulating among monkeys and mosquitoes, or maybe among bats and no mosquitoes, for quite a long time before it spilled over to humans. So it's kind of like the case of, if a tree falls in the forest and nobody is there, we don't know that the infection is there until we actually get involved. An example is, again, with West Nile virus, and I mention it because that's an ongoing study we have here at Emory that has involved, over the 9 years I've been here, a large number of undergraduate, public health, and PhD students conducting field work on mosquitoes and on birds, trying to understand why actually there isn't so much human West Nile virus in the South in comparison to the Midwest, to the Northeast, to the Mid-Atlantic. And that's a paper with a nice picture of the cardinal that came recently and got a lot of attention, in part because cardinals are so photogenic, and actually showed that having cardinals here is somewhat protective. They suppress the transmission and they prevent or hamper the spillover of West Nile virus to humans. But let's go back to Zika, and I can't talk about Zika without talking about really mentioning 3 other related viruses. One is dengue, which is the most important mosquito-borne viral disease in the world, possibly already the most important mosquito-borne disease in the world, maybe more than malaria. Growing, because it does well in urban environment, with many millions of cases every year. And the other 2, which I won't talk about very much, are chikungunya and yellow fever, which used to be a huge problem, including in much of the US. There were big outbreaks in New Orleans and Philadelphia. With the development of a vaccine, it was pretty much eliminated, but it's now coming back in several places, and I may have a chance to mention that as well. So, why do we have more of those mosquito-borne diseases? I already mentioned that there are many more of us, and more and more of us are living in urban areas. In fact, as of I think 2 or 3 years ago, the majority of people live in urban areas for the first time. Many of those urban areas have been developed in an uncontrolled fashion, which means we don't have basic services. We have many habitats for the mosquitoes, containers, tires, and a variety of other refuge. There are limited resources to conduct vector control, mosquito control, including in many places in the US, and we are moving much farther and much faster. And in fact, any one of us, which means any virus or any mosquito, can be anywhere within 24 hours. We'll come back to that shortly. So what is Zika virus? Zika virus is from a group of viruses called Flaviviruses. It includes also the West Nile virus mosquito, the dengue mosquito, and the yellow fever mosquitoes. It's transmitted primarily by a daytime mosquito called Aedes aegypti, one that is feeding only on humans, that is adapted very well to the urban environment and does not need much water in order to lay its eggs and for its larvae to develop. The whole life cycle of the mosquito for full transmission cycle takes about 2 weeks. If a mosquito feeds on an infected human, it will take maybe 4 days to a week for the virus to develop in the mosquito and be ready to be transmitted. And then if it, in the human, it may take 5 to 10 days till the human will show symptoms, if the human will show symptoms. Again, we'll come back to that in a few minutes. So where did Zika come from? Well, it actually came from the Zika forest in Uganda. It was discovered there in the late 1940s, and it was considered a virus that is transmitted between mosquitoes and monkeys with really very little public health interest, although people knew that there is a chance for humans to get infected. So it was kind of one of many viruses we have found in the tropics that we kind of said, okay, we'll check on the list of another virus and not think about it too much. It has spread around. There was a human case of Zika in the early 1950s. There were several, but very few cases during the 1960s, 70s, 80s, primarily in Africa, but also in Southeast Asia. And then in the mid-2000s, there was the first outbreak of Zika virus infection in humans in the Pacific, in Yap Island. And there we had, it was still mostly a mild disease, low fever, a characteristic rash called exanthema, sometimes some infection of the eye, conjunctivitis, but generally in most cases it was not considered a serious disease. Then about 7 years later, about 5 years ago, there was a larger outbreak in French Polynesia, and that one, although again most cases were mild, there were some complications, neurological complications called Guillain-Barré syndrome, and it started attracting a little bit more attention. If we look at the historical spread of Zika, so it probably started from Uganda, it went to Southeast Asia, to Polynesia, went across the Pacific, made it to South America, and then finally made it to Brazil and exploded in Brazil. It is now found in pretty much all of South America, all of the Caribbean, much of Southeast Asia, Florida, Texas, Singapore, etc. And there's no reason to assume that it will not spread farther to the tropics and the subtropics. Anywhere where the Aedes aegypti mosquito is common. Again, it's a arboviruses and originally a zoonotic virus, which means transmitted between humans and between mosquitoes and non-humans, and then it spilled over to humans, and now we have an urban cycle that needs only the mosquitoes and the humans. We don't need the monkey for it to continue to be transmitted. This is, for example, very different from West Nile virus, where humans are accidental hosts, but for transmission we need the bird and mosquito cycle. The issue of spillover of zoonoses, of diseases of animals to human cycle, is very interesting. It happened not only with Zika, it happened with yellow fever that probably came from Africa into the Americas with the slave trade and became a major epidemic in Brazil, in much of Central America, and as I already mentioned, there were very big outbreaks in New Orleans repeatedly and several in Philadelphia as well. Right now, we actually have a large outbreak in Brazil following one in Africa that partially is because immunization does not occur as regularly as it used to be, and we have a relatively large populations of unimmunized people which are susceptible to yellow fever. In theory, if we can vaccinate everybody, we can control yellow fever. That is not the case for dengue or for chikungunya or for Zika, that matter, for which we don't have a vaccine yet. Both of them originated also in the tropics, in Africa or in Southeast Asia, moved probably with ships to the Americas, the dengue quite a long time ago, chikungunya more recently, and again found a very favorable environment, the right kind of mosquito vectors, and are doing very well in the New World. So let's talk a little bit about what happened in Brazil and try and understand a little bit more what Zika actually does. It was first described 2 years ago, in March in 2015, in northeastern Brazil. There was an outbreak of a mild disease with mild fever and a rash between March and June 2015. I'll come back to that in a minute. And again, people did not get too concerned about it. They figured it was Zika virus and they said, okay, so you get it, you never get it again, you're immune, could be much worse. A little later, we started to observe cases that are more serious, specifically of the Guillain-Barré syndrome, which can result in serious neurological complications, and then much more seriously in the winter down south, summer here in July, September of 2015, obstetricians started to identify more cases of congenital abnormalities and specifically microcephaly in newborns in northeast Brazil. And that's really what attracted a lot of attention to Zika. Why did it happen in Brazil? Well, we talked about urbanization. Brazil exemplified the explosive rate of urbanization. In Brazil, in the 1950s, we maybe had 20% of people living in cities. Now we have 80%. It is now one of the most urbanized cities, countries in the world, with several huge cities that have, developed very rapidly, with limited opportunities for infrastructures and mosquito control efforts. If you're a, Zika carrying mosquito, it's about as good as it can get. In addition, and partly because of that, Brazil has the highest number of dengue cases in the world. And that relates to urbanization, but it has been explosive with large outbreak pretty much in every city in Brazil. So it means that conditions for another virus that is transmitted in a very similar fashion were very favorable. And finally, it may have been bad luck or circumstances. Initially, people thought that either the World Cup, the Soccer World Cup in 2014, or the World Sprint Championship canoe race were how the virus came in. Doing genetic analysis, it probably came in a year earlier, but also in some international events, the 2013 Confederation Cup, which was a precursor to the World Cup, or another boat race. It's probably how it made it to Brazil. So just maybe being in the wrong place at the wrong time had something to do with it. As I said, initially the disease was not considered very serious, the mild fever and this rash, which was very typical. So people noticed it, and we knew that there was something new, because that kind of a rash with many people is not typical. And pretty rapidly the association with Zika virus, which was surprising, was determined. And again, this was in spring or fall 2015 in Brazil, and it was considered of interest, but not much beyond that. Then a little later, the connection to Guillain-Barré syndrome, to this neurological syndrome, was suggested, and people started paying a little more attention to it because there are other viruses that cause neurological complications. West Nile virus can cause that, but even measles can cause that. So that was not as unusual. What really attracted attention is the sudden increase in microcephaly for a variety of reasons. First of all, microcephaly is a very visible and very horrifying symptoms. It affects newborn, which is, really about scary as it can get for any couple or, potential parents. And it happened relatively quick, and there was a large number. Usually microcephaly is a very rare condition, but there were hundreds of cases diagnosed in northeast Brazil, especially in the large cities of Pernambuco and in Salvador when I've been working. And that caused a huge amount of attention. I'm sure many of you, probably heard about Zika first when the connection to microcephaly was determined and published. And this is still receiving a lot of attention. This is from the New York Times Magazine, I think a week or two ago, following the long-term impact of Zika virus. Because if you have a baby with neurological complications, especially something like microcephaly, that is a lifelong, issue, lifelong suffering and lifelong cost as well. So how will the public health system, which is struggling anyhow, deal with the incredible cost of having to help care for those children is a huge challenge for which we really don't have good answers as yet. So let me talk a little bit about the studies that we have been doing in Salvador, Bahia. And those have been collaborative studies with a group of researchers in Salvador. It's one of the largest cities of Brazil. There's about 3 million people. It is known for extensive transmission of dengue, and it was one of the places where the first outbreak of Zika and the other virus I mentioned, Chikungunya, happened in 2015. It's a collaboration of us at Emory, some people from CDC, the Federal University of Bahia, and the main research institute of Brazil, Fiocruz or Instituto Oswaldo Cruz, as well as the city health department, and that was important. It was important because the city health department got onto this very early and started recording cases. And most other cities did not do that. Because they did that, we could actually create an epidemiological curve, which you see here, of the cases of the probably Zika virus. We call it, let's say in red, acute exanthematous illness, because we are not sure, we couldn't actually do the test to diagnose the Zika, but we are very confident that the vast majority of those cases in red are actually Zika cases. And this type of curve, it goes up pretty rapidly, reaches a peak and goes down, is very typical when you're introducing a new disease and you have a large outbreak. Everybody is susceptible, there is no immunity, a lot of people get infected, it kind of goes through like a wildfire, and then it slows down. And we think a huge number, maybe as many as 2/3 of the people in Salvador have been exposed to Zika virus, but again, we don't know that. And 80% of the people, that's the estimate, do not show any symptoms. So it's really very hard to tell how many people were infected, but we feel comfortable that this study that was published in the CDC Emerging Infectious Disease Journal is a really good representation of what happened in April to June 2015. Because we had all this data and because people are very interested about the potential connection between Zika, Guillain-Barré syndrome, and microcephaly, we tried to map temporally the occurrence of the three events. So here is the graph very similar to what you've seen before of the outbreak of Zika, the outbreak of the rash and fever. Here are the cases of the global Guillain-Barré syndrome, and most important, here are the cases of the microcephaly. This really is, it's not a proof of causality, but it's a very strong evidence, statistically demonstrated, for a temporal relationship between the timing of infection and the birth outcome. Really what this shows is that the peak in microcephaly cases occur about 6 months after the big outbreak of Zika virus, which supports very much the idea that if you get infected during the first trimester of pregnancy, that is when you're at highest risk for those congenital complications, specifically microcephaly. One thing that we found out later, we just published that recently, that the other virus that was also introduced around that time may also have played an important role. And what we titled our article, A Silent Epidemic of Chikungunya During the Big Epidemic of Zika. Probably what happened is there was so much Zika virus around with this characteristic rash that we missed out on the cases of chikungunya. And that may be important because maybe having those two viruses together has to do something with the fact that microcephaly was found primarily in northeast Brazil. When Zika started spreading farther north into the Caribbean, into Central America, even into Florida, people were very worried about an explosive outbreak of microcephaly. That has not happened. In fact, one of the big questions for which we don't have any answer yet is, why isn't there more microcephaly in other places? Why has it been really not limited? Because we do have microcephaly in Colombia, in Mexico, even in some travelers that have returned to the US. But the big explosion happened only in northeast Brazil. It may have to do with chikungunya there. It may have to do with the population was exposed to dengue before. It may have to do with something else circulating, socioeconomic conditions, a combination of factors. We don't know, but this is one possible explanation that we propose. The other thing we've done in that area, we have an in-depth ongoing study in one poor area, we call the slum here, in Salvador, Brazil. We've been studying for a long time. It's an area that has about 200,000 people. We have a health center we've worked very closely with, and we've been testing people there for dengue, Zika, and chikungunya for many years. I don't really want to talk so much about this study. I don't have the time, but it's a good demonstration of what an area that is conducive to transmission actually looks like. And it also is a perfect demonstration of the rate of urbanization. In 1959, this was pretty much an unpopulated area. People have moved in there, and you can see the change from 1959 to the 70s and 80s to 2000, where it's completely and very crowdedly populated with hundreds of thousands of people. So from an area where the mosquito probably could not even survive, it became an area which is very conducive to the development of the mosquitoes, with many containers, catch basins, other areas where the mosquitoes can develop, many people, which means it's very easy to transmit the virus, whether it's dengue or Zika or Chikungunya, between people. Let me talk a little bit about interventions and what we can do about vector-borne mosquitoes, about vector-borne diseases. First of all, there is treatment. The big problem is that for viral diseases, we really don't have very good prevention or treatment, except for the ones for which we have vaccines. So we have a vaccine for yellow fever. We don't have a vaccine for dengue. It's been a struggle for a long time because dengue has many different strains. And it's very difficult to get a vaccine that will work against all of them and not cause side effects. I think we will have a vaccine against Zika, but initially I thought it would be, within a year or two from now. I think it may take a little longer. We have treatment, to address the symptoms, but we don't have anything that actually deals with the virus directly. So most of what we can do is indirectly, and primarily what has been done is to try and control the mosquitoes or to reduce opportunities for contact between mosquitoes and humans. There are all kinds of other interventions as well, and I always say that, something like Zika, it's too important to leave it to health professionals alone. I'll come back to that at the end. So as far as vector control, people try to control either the larvae or the adults. Generally, it's easier to control the larvae because they are in confined containers, but it's very hard to reach all the different containers that a mosquito such as the Zika and dengue mosquito can breed in. And then there are control efforts that you can conduct against the adults, spraying and fogging in different fashions. Generally, larval control measures are taking place continuously, and adult controls are often a reaction to an outbreak, so more of an emergency measure. Sorry. And then, of course, there is mass education. I already showed you some of those posters, and get the public involved. When the Zika outbreak was at its peak, the government mobilized the whole army to go out, help educate people, and help address the source reduction, trying to deal with the containers and the public health efforts. It's not always easy because there are many areas where the army is not trusted, or in general the government is not trusted, so it doesn't always work. You can't just come and say, oh, we really want to help you and educate you with a background of mistrust that may have been there for decades. Another interesting thing that we found in our study in Salvador is that generally people think of the Aedes aegypti mosquito, the vector of Zika and dengue, of one that is breeding in containers. What we found that is not always the case. In the one study area, we kept finding mosquitoes. We knew there were cases of dengue and Zika, and we couldn't find where the larvae and the pupae are developing. And eventually we started looking at catch basins or storm drains. Oops, I didn't mean to do that. And we found that those are very conducive both for the development of larvae and pupae and as resting areas for adults. So this is very important because it means that we may be looking like the drunk looking for the coin under the light rather than where the mosquitoes actually are. And we need to consider that the mosquito has adapted. It has moved from the forest to the cities. It has moved from Africa to Miami. So there's no reason to assume it is not going to adapt also to developing in other places, including catch basins and many other, and maybe other ones as well. The nice thing is that in that suburb we found it's a relatively affluent suburbs of Salvador. The community actually organized and decided to treat all the catch basin, to cement over the bottom where the water accumulates, so there will not be any much standing water, and they really eliminate the mosquito population from that area. We think they also reduce the chance of transmission, but it's too early to tell. We don't have enough data yet. In general, in order to control a mosquito-borne disease, truly any health challenge, we have to address the underlying issues, which are cultural, socioeconomic, demographic, and others. And often we don't do that. We leave the disease control program and responsibility to the people that are specifically in charge of that disease rather than involve the whole community. Success stories in general, and probably AIDS, HIV represent a story like that, is it has to be a combination of community efforts, public health efforts, and a variety of not directly health-related strategies as well. Let me talk a little bit about Zika in Florida, because that was, of course, very interesting. When people asked us, do we expect Zika to make it to the US, continental US? It's made it to Puerto Rico and to the Virgin Islands, and there's been explosive outbreak in those parts of the US, which we have to remember. It's not only the continental US, but we always said it's very likely that we'll have Zika cases in Florida and in Texas. We don't think there will be a huge outbreak. That is exactly what happened in Florida. Those slides I got from a colleague, Audrey Landhart, at the CDC. And as you know, there was an outbreak of Zika virus in Florida primarily in June, July of last year. There were quite a few cases, and there was a very quick response to it. It was concentrated initially in one neighborhood, in one of Miami called Wynwood. It spilled over to a few other areas of Dade County as well. And there was much reaction right away. There was an attempt to control and collect all kinds of containers. There was a spraying effort. There was a call to put all your trash outside, which people use to put a variety of trash. What you see out there is not very conducive to mosquito breeding, but I guess it's good to get rid of trash anyhow. And there was even aerial spray, which raised some concerns. Some people are not happy about spraying in general, specifically spraying of adulticide. The spraying was effective. What this graph is showing is the arrows are when there was actually spraying activities, either from a truck or from a plane, and how following a spraying event, the number of mosquitoes was reduced very, very drastically. So clearly, it was an outbreak, an emergency reaction made a lot of sense, but it's not a clear solution for the community. I mean, many people feel that the cure may be worse than the disease, and that using pesticides can be very risky. It really depends what kind of pesticides you're using it, how you're using it, and is the cure really worse than the disease? And when you talk about something like Zika and the risk for the newborns, you really are talking about something that, although the risk may be low, the outcome can be so severe that it will, enhance your willingness to employ a variety of measures. But it is a question, it's always a question when we are spraying for mosquitoes. It's still an ongoing story. One of the things, and I'm near the end of what I want to say, is that Zika has been full of surprises. The fact that we got the microcephaly was a huge surprise. The fact that we actually found that Zika can also be transmitted through sexual intercourse was a huge surprise, very unusual for any mosquito-borne virus. It's not the main way that Zika is transmitted. It's primarily a mosquito-borne disease, but it can be transmitted in other ways, which raise a variety of issues about control, preventions, and protection. Those are some very recent titles that I've collected them, from last week about the warning of sperm donate in South Florida at higher risk of Zika, the fact that we are preparing for a long war, the bottom one from The Guardian, that nervous system birth defects are 20 times more likely for Zika hit mothers. And that's important because microcephaly is probably the extreme congenital outcome. but it's very likely that we're going to find a variety of other symptoms affecting the eyes, the ears, and other ones that you may not notice for another year or two, but may be related to Zika. So it's an ongoing developing story, and I presume that Zika will continue to surprise us. It's still spreading globally. It is, as I said, it's now found, in the Americas. We found it in Florida. There was transmission in Texas reported this spring in Brownsville, and I think it's very likely we'll have limited outbreaks again in the southern US. And globally, I think the areas where it has not made it yet, especially in Southeast Asia, it's very likely we'll find it this year as well. I want to finish and talk about some ethical issues that Zika is raising, because it's clearly more than just a health matter or a virus transmitted by a mosquito. One issue, of course, the issue of inequality. Although you can get Zika or dengue everywhere, you are more at risk if you are poor, if you live in an undeveloped area, if you live in an area where public access to public health is much more limited. As I always tell the story that when Zika came to Brazil, in São Paulo, some very affluent people, pregnant women, went to Europe for 3 or 4 months to avoid being in Brazil during the first trimester of the pregnancy. That's clearly not an option for people that live in the slum area that I showed you earlier. The issue of reproductive rights. Brazil is interesting because the availability of contraceptives is universal. I mean, wherever you can get a condom for free everywhere, but abortion is illegal. Which again means that if you're, rich and you want to have an abortion, you'll have it. If you're poor, it's going to be much trickier. The issue of gender. Initially, all the attention was of women because they give birth, and then it was found out that there is, potential of transmission through semen, and that men actually can harbor the virus for much longer than women, and maybe at higher risk for transmitting it that way. So it's related to, if we have a pandemic, what can we do? What should we do? Should we apply the mosquito control measures? DDT is an example of a, insecticide that got a lot of bad rap, but probably it got the bad rap for its use in agriculture. The use against mosquitoes was not as harmful, also was relatively much, percentage-wise it was minuscule compared to the use in agriculture. The use of genetically modified mosquitoes is a big question. People are now releasing sterile males, mosquitoes infected with Wolbachia, which is a bacteria, and genetically modified mosquitoes. None of this is going to be a magic solution, a magic bullet, but all of those may add to our arsenals of trying to control mosquitoes. One interesting question that I've been asked a few times is, if we could eradicate a mosquito species, should we do it? It's not possible. Really, our success rate of eradicating species is very poor, but we also don't know what the implications will be. So just because a species seems to be a very annoying one does not mean that getting rid of it is a logical solution when we consider the whole food web and the ecosystem. And finally, I think Zika demonstrated many different phases of science. There was some very good collaborative science of people from Brazil working together with other people from Brazil, from other people from Latin America, and from people from the US and Europe. But there were also what I call parachute science, where scientists came and said, give us all our data, we'll take it, and we'll solve the problem, which has been, definitely an issue that has been raised in Brazil and in other places as well. So I think I'll stop now and give time for questions. This last slide is actually interesting because it shows us doing pretty much the same thing in the US and in Brazil, where we collect larvae from catch basins. In fact, the guy who's standing up on the left right here is one of our Brazilian students that came to work with us for 6 months in the US, and here he's doing the same in Atlanta. So the idea of collaborating with other universities, working with other research institutions, giving opportunities to students from abroad to come and work here and for our students to come and work there is something that we are really supporting and I think is a priority for Emory. And now I really finish. Thank you.
Great. thank you, Dr. Catrone. So now we will move on to the questions section. Just a reminder that we will start with the questions that were sent in during the registration process, but please feel free to ask some questions as well in the little, I guess it's a little section that is marked questions. You can type in your question, and if we have time, we of course will get to it as well. So we will go ahead and start with, and some of these might have already been answered throughout the presentation, but I will leave it to Dr. Catrone to expand upon them or just kind of move on.
Okay, so this is a question about genetic modification of Aedes aegypti. I don't think it will eradicate either the virus or the disease. I think genetic modification is really a wide term. I mean, we can talk about what's called sterile males. People are talking about releasing in the keys, which is basically males that cannot reproduce. There is no risk in that, but it's a very expensive method because you have to do it again and again. It may help. I don't think it will add something, but not that much. There is, as I mentioned, a bacteria which is naturally found in insect called Wolbachia, and that one has been introduced to Aedes aegypti mosquitoes and has shown some promise in Southeast Asia and is being tried in Brazil as well. Again, because this is a naturally occurring bacteria in the mosquitoes, I'm not worried about that one. And again, I don't think it will be a magic bullet, but it can add to the arsenal of tools that we have to control mosquito-borne diseases. Actually, modifying genetic mosquitoes are effort on that as well. That one does raise some questions about what will happen if the mosquito will become a good vector for other viruses. So far, it has been controlled very tightly, and making sure that the mosquitoes will not spread further has been maintained. So I think that way the general issue of genetically modified mosquitoes or genetically modified crops for that matter. All in all, I think that the two first methods are legitimate. The third one may be a little bit questionable, but I certainly do not expect them to eradicate either the virus or the mosquitoes.
All right. So moving on, somebody asked, having been to Mexico recently, we saw / experienced absolutely no mosquito activity. What is being sprayed to prevent their appearance? How toxic is it? How long does it last? I understand the benefits, but want to also understand the impacts of our chemical reaction.
Okay, so Mexico has experienced Zika primarily along the Pacific coast, a little bit less on the Gulf. Right now, if you came back from Mexico recently, it's a slow period. It will really pick up, in the summer, June, July towards November. So that's no surprise you didn't see so many mosquitoes. And of course, Mexico has a range of altitude. So the mosquitoes are not found in high altitude. Mexico City is not a problem because we don't have those mosquitoes there. As far as what is being done, again, it varies in different areas of Mexico. In the tourist towns, so if you talk about Acapulco, you talk on the one side, talk about Merida or Cancun, the other side, then we do have mosquito control efforts, and mostly they are targeting against nuisance mosquitoes so that you, when you go there, will not notice too many mosquitoes. I presume that those measures are not that different than what is being conducted by mosquito control districts in the US, especially in the southern US, and most of them are probably targeting the larvae, which means that you don't have to worry about toxicity as well.
All right. Would it be safe to expose young adults to the Zika virus in endemic areas?
That is a really good question. Initially, we thought, well, now that we know that Zika is a mild disease, but given the horrible, implication it can cause for, if you're giving birth, maybe it would be good to kind of, have Zika infection parties. I think they used to have them like with chicken pox in the past, so they would get all the kids together, get it out of the way. If I had a young daughter, I think I would kind of be relieved if she had Zika early on and we could cross it out because we don't get Zika again. The problem is that we do find that Zika does have some different complications. I mentioned the neurological Guillain-Barré syndrome, and now we are finding some other ones as well. So I don't think I could recommend exposing young adults to Zika in endemic areas until we know more about the possible complications, even when disease is mild or inapparent. But it's a tough one. I mean, given the high risk, again, I think you would breathe a sigh of relief if your young, boy or daughter, son or daughter, were exposed, got some mild disease, and got it out of the way.
All right, so the next one is a three-parter. So is there a time of day or weather conditions in which the Zika-infected mosquitoes tend to be more active? Any screening I should undertake after a series of mosquito bites? And anything to include in my diet which discourages the mosquitoes, rendering my blood less appealing? Yes, please.
Okay, so the first one is easy. Those are daytime biters. So if you're bitten at night, it's probably by other kind of mosquitoes. Although, as an aside, I mentioned how those mosquitoes seem to be very adaptive. It seems like now we find Aedes mosquitoes active earlier in the morning and later in the evening as well. But primarily they're active during the daytime. They need water, but interestingly, actually, a drought after a heavy rain may be very conducive because people collect a lot of water. So weather conditions are important, but it's not just an easy correlation. The more rain you have, the more mosquitoes you have. In fact, one of the things we found that unpredictable water supply was the highest risk factors, because when people not only don't have regular water, but have water, they don't know which day, one week will be Monday, one week will be Thursday, they will collect more water for a longer period of time, which will mean that there are good breeding sites for mosquitoes to develop. In general, if it's really, really dry, mosquitoes are not that, adult mosquitoes are not that active. So in the desert, those are not very conducive conditions. Right now, we don't do any screening for viruses you've bitten by mosquitoes, unless you are a pregnant woman that have been potentially exposed to Zika. There are tests, but they are not commonly being applied. As far as diet, I wish. People talk about garlic being unappealing to them. I don't think there have been any controlled studies showing that.
All right. Moving on, so what population connectivity factors are more informative to understand where Zika, given its transmission dynamics, may spread?
So that's a good question. I think we need to think about at different scales. I mean, there is a spread within a neighborhood or a city, which is relatively very easy. There is a spread between cities, and then there is global spread. The Aedes mosquitoes is not a good flyer. It rarely flies more than, less than 100 meters, and often much less than that. So the movement of the mosquitoes is very slow. But of course, humans can move the virus very rapidly, and the mosquitoes are very good hitchhikers. As I said, they came to the Aedes aegypti came to the New World in Africa, probably on slave boats and through other, trade. We find mosquitoes on planes, which means any mosquito, and again, any virus in a mosquito or in a human, can hop from one place to the other within 12 or 24 hours. So I don't think there is much we can do to prevent the arrival of Zika virus to new areas. What we can do is a very targeted control in areas where an outbreak takes place. I think that's what took place in Miami, for example. We did a study in Australia for an outbreak of dengue in one city, showed that by targeting and spraying to houses where cases occurred and around those houses was much more effective than targeting in general. So it's more how to react to the spread than actually to preventing the spread.
All right, so now we will move on to the questions that have been asked during the presentation. And Susan asked, have there been any microcephaly cases in 2017?
Yes, there have been microcephaly cases. The number in Brazil after 2015 has gone way down. So there weren't that many last year or this year, but we have had microcephaly cases, a few throughout the world really, including in the US and Mexico. The number has been small, as I mentioned before. Outside of Brazil, the number has been small in general. But the answer is yes.
Okay, and then Hugh also had a question about microcephaly, and he said, can you further comment on the idea that microcephaly clusters in Brazil may be related to co-infection?
So I think it's possible. So we think the prior infection with several strains of dengue, which most of the Salvador populations have experienced, coupled with the simultaneous introduction of chikungunya and possibly other virus circulating, may have something to do with it. So it's definitely one, at least partial explanation for the mystery of why we have so much more Zika in Brazil and specifically in Northeast Brazil.
All right, and then Malcolm and Jordan had similar questions. Because of the mild winter in the U.S., do you see Zika pushing further north, specifically to Atlanta, Georgia?
Right. So the Aedes aegypti mosquitoes is found primarily in Florida, in South Florida, and in southern Texas. But it has been spreading in the U.S. There are foci in the Washington, D.C. area and several in California as well. In general, I think that milder weather will be conducive to Aedes aegypti spreading slowly up north. I don't think it will make it to Atlanta just this year, but that's something we are lookout actually. We actually promised our students a prize for the first one that we find Aedes aegypti in Atlanta, Georgia. But there's only one focus south of Macon that we know of in Georgia.
All right. Africa has urbanized rapidly. Why have there not been significant Zika outbreaks there?
A very good question. And the same is true for dengue and a variety of other arboviruses. There are two possibilities. First of all, it's quite possible that there have been outbreaks of Zika and dengue for that matter, but they have been relatively asymptomatic because people have been exposed to a variety of other viruses beforehand. We have an ongoing study in Kenya where we're looking specifically at the prevalence of arboviruses, including dengue, chikungunya, and Zika, and we found there is much more of it than is assumed, and that many fever cases that traditionally are attributed to malaria actually may be caused by those viruses. So I think there is more of it in Africa that we are missing, and that may be the main explanation for why we don't heal so much or diagnose it as possible.
Okay, and then we did have one commenter say that there are certain types of food that may be more appealing to mosquitoes, such as bananas and sweeter fruits. Are there any other foods that we should avoid if we're traveling to a to a Zika-infected area?
Right. So as far as I know, there's a lot of kind of common wisdom about the kind of foods that will help or don't help. There are no clear data. There is no magic food that you can take that will really prevent mosquitoes from feeding on you. Nor is there one that will definitely make you more attracted to mosquitoes. The study of why mosquitoes are more attracted to certain people is a fascinating one. We all know, I'm sure if you've gone camping or gone out with people, some people are just a magnet for mosquitoes. Some people the mosquitoes completely avoid. We always like to have as friends the first group of people. But the truth is that it's a complex factors of what we emit. Lactic acid has been suggested, amount of CO2, a variety of other factors. We haven't completely determined what is the perfect attractant for mosquitoes. People are working on it because attraction traps are a really good way both to do a surveillance of mosquito population and a potential control effort. So people are doing a lot of work on that, but the magic formula has not been deciphered as yet.
All right, so that is it for the questions. We want to thank everyone for joining us here today, and of course thank Dr. Catrone for his wonderful presentation. We have recorded this webinar, and so we will be posting it online, and we will be following up with the link to that as well as some additional information. Of course, please feel free to reach out to anyone from our team if you have specific questions or any needs. And thank you all so much for joining us again.
Thank you. It was a pleasure.